Yes? Well, my husband and I will come round and see you in the morning.
Good morning.
Well, how do we start? Frankly, electricity is one of life's mysteries to me, so we shall appreciate your help.
With pleasure. You want to have your house wired. You can have it done with tubing or with one of the surface wiring systems. Tubing is rather expensive unless it is put in while the house is being built.
Is there much difference in the prices?
With a surface wiring installation, the cost is 3/4 that of tubing.
A surface wiring seems to be the thing.
Well, it comes to this. The type you require and the cost.
Quite. Now, what are they?
I would suggest BI, British Insulated Cables. These show boards will explain them.
Oh.
What worried us is having the walls damaged.
That isn't necessary. This system can be laid on the surface without any damage.
Splendid. That's what we want.
Take this, for instance, the hills between. This consists of twin conductors, insulated with India rubber and sheathed with the lead alloy.
Oh.
This sheathing provides a metallic cover which is connected to earth and ensures against shocks. The connections are as sound as they are simple.
Oh, the boxes are certainly a neat job.
Yes, they've been designed to be as unobtrusive as possible. Now, here's another system, the CTS. This has a covering of tough rubber instead of metal, which would suit you just as well. The box is made of bakelite.
Oh, yes. Used a lot in wireless.
That's right.
What a lot of wiring systems.
Yes, we have one for every purpose, and they're all good. You see, the BI make those large cables that you see in the street very often, and they have a reputation to maintain. I wonder if you would care to see how cables and house wires are made. I have a film which will show you far better than I could tell you.
Rather.
That would be nice.
We should really call this the birthplace of the cable, for we are in the latest of the 3 rolling mills at Prescot, where mill bars weighing 250 pounds are rolled down into a rod of 1/4 inch diameter. These bars are mechanically lifted and rammed onto the bed of an oil-fired furnace, which heats them up to a bright red heat, ready for the rolls. The entry of a cold bar pushes out a heated bar onto the live rolls, which convey the bar to the breaking down rolls, the first step in the reduction of the thickness of the bar. Backwards and forwards it goes on its reducing course, a much quicker process than that to which some ladies submit, and with much quicker results. Four passes, and the bar is now sufficiently elongated and flexible for the intermediate rolls. The curved repeater channel does away with the necessity of handling the copper between passes. After passing through the intermediate rolls, the 250-pound bar has been elongated to a flat oval strip, very dexterously handled by the operator. We are now going over, as the radio announcers say, to the finishing train, where a channel is used on one side only. When the copper emerges from the back of it, it is a round section, suitable for travelling round a repeater channel to the return pass. Coming from this return pass, however, it is in a flat oval section, and the copper has to be caught by a man, given half a twist, and pushed into the next pass, where exactly the same processes occur. Now watch the slow motion and see the amazing skill and speed of these men. Thus, in a space of a few minutes, the copper bar has been reduced to a rod of 1,250 feet, which is passed to the continuous running winders. These winders drop the coils onto a travelling platform, which delivers the coils to an underground conveyor. After the rods have been pickled to remove scale, they are ready for the drawing machines, which convert the rough copper rod to bright wire. We are now in the wire drawing shop, where the quarter-inch rod, in being drawn down, is passed in succession through 9 dies drilled with trumpet-shaped holes, each hole effecting a progressive reduction in the diameter of the wire until it reaches the diameter of 0.062 of an inch. This type of wire is used in cables, for winding motors and other purposes where appreciable current is carried. Machines working on a similar principle are used for drawing wire down to sizes as small as 1,000th part of an inch, half the thickness of a human hair. These wires were almost too fine to photograph, so we had to cause an halation. These fine wires are used in the making up of flexible leads, the winding of telephone receivers, wireless components and other purposes. It's rather interesting to record that in the East, weavers sometimes incorporate strands of copper wire into the fabric which they manufacture. Fine wires are usually wound direct onto spools suitable for the machines where the wire will be laid up into flexibles or the wire coated with enamel. Generally speaking, electrical conductors consist of a number of wires stranded together on machines such as these. The numbers run in the progression 7, 19, 37, 61, 91, up to the largest stranded conductor of 127. Paper was first used as an insulator by Dr. Ferranti. The first paper-insulated electric cable in Europe was made by the BI. Watch them being made today. After the insulation of the individual conductors, they are placed in a laying-up machine for the construction of cables containing 3 or more cores. The spaces between conductors are filled with jute, which gives a firm bed to the cores. Now another insulation of paper. As many as 70 papers, giving a thickness of 1/3 of an inch, can be put on in one operation. This machine is actually putting on 24 lappings. A slow motion picture shows you how perfectly the machine does the lapping. Now we come to the largest laying-up machine in this country, dealing with 3 cores, each insulated for 33,000 volts and covered with a lead sheet. The The metal sheath on the individual conductors is to ensure even radial electrical stress on the insulation, a very important matter where high working pressures are involved. The spaces between the lead-covered conductors are filled in with jute. As the conductors and jute are laid together, you can see how perfectly they form, ready for the paper insulation. A thorough impregnation of the insulation is essential before the cable is covered with a sheath of lead. This hydraulic press forces lead round the cable, which, when formed, provides a sure barrier against moisture. We are now in the test house, where all cables are immersed in a water tank for a period of 24 hours. Any defects of the lead sheath cause ingress of water to the cable, which is immediately discovered when the cable comes to be tested. Cables are tested for insulation and subjected to a pressure test of several times the voltage at which they will be put to work. Between the tanks, they are measuring cables and cutting them to length to suit customers' requirements, which are governed by the distance between the joint boxes and other similar conditions. Lead, of course, is a protection against moisture, but lead in its turn must be protected against damage. So we have brought you to the armouring shop, where steel wires are laid onto a bed of jute string. Another method of protection is provided by steel tapes, which are put on in such a manner that one tape covers the gap of the spiral formed by the other tape. So far, we have shown you cables used for heavy current. In this shop, cables for the transmission of the minute currents at low voltages used in telephony are manufactured. Telephone cables, instead of a few large conductors substantially insulated, consist of a number of small conductors, amounting in an extreme case to 2700. These are insulated with a single wrapping of dry paper. Another type of conductor, such as those used for winding coils of dynamos and motors, is covered with cotton. Cotton is received from the mill, wound in an elongated form called a cop. For use on the covering machine, it is necessary to wind it in the flat-ended form called a cheese. The cheese has a hole through which the wire to be covered passes. The cotton is rapidly spun round the wire at suitable tension by an arm revolving at approximately 3,000 revolutions a minute, the cheese paying off cotton as it is used up by the wire. The high speed is realized when we turn on our slow motion camera. This machine is shown revolving at only 1/10 of its normal speed. In many cases, conductors are cotton covered by braiding. Sometimes the braiding is put onto the bare conductor, and in other cases on top of a cotton covering. The merit of a braided covering is that it will not seriously fray, and that it is so easy to handle. As you see, the braiding is done on the maypole system. Just a minute. You can see more clearly through our slow motion camera. Here is a larger machine. We should mention that a braided covering is often impregnated with a compound of a character to suit the conditions which have to be met. The BI are particularly successful with the compounded braided wires which they supply for overhead lines in all parts of the world. We must also give ourselves a pat on the back for being the first to evolve a twin lead-covered wire for domestic installation. This machine is applying the paper insulation to the two conductors. Leaving cables for a moment, we'll glance at one or two of the other activities of the Prescot works. Resistance welders, for instance. Did you know that the BI manufacture all types of resistance welders? This is the bond shop. These bonds are used for rail joints on electric railway or tram lines. Nearby, a battery of drop hammers are forging bond heads. The BI make their own cable drums, and to utilize wood which would otherwise be waste, they have put down a plant for the making of firewood. A sideline, of course, but it has the advantage of preventing waste and showing a profit. We are now in the export department, where cable drums are lagged, painted and prepared for dispatch. Running along the centre is a battery tractor, so designed that the operator can, without assistance, pick up and transport drums of cable up to 5.5 tons. This is the huge store yard containing nearly 2,000 drums. You can see how the travelling Goliath crane facilitates the handling of drums, particularly in loading the lorries that convey the finished product from our Prescot works. Two miles from Prescot is the Highton Quarry factory of the BI, where enamelled wire is made. The wire has first to be wound onto special reels in preparation for the enamelling machines. The enamel is applied by passing the wire through a bath and then an oven of closely regulated temperature, which bakes the enamel to a tough and elastic consistency. The process of immersing and baking the wire is repeated several times until a coating of enamel of adequate thickness is built up for the purpose to which the wire will be put. The enamel used has extraordinary qualities as an insulator, and in nearly all cases is the only insulation with which the wire is provided. It will stand, without deterioration, temperatures which would destroy insulation of a fibrous character. Enamelled wires are used almost exclusively where the space factor is of importance, as in telephone receivers, wireless apparatus. We are now in the Helsby Works near Warrington, where rubber insulating and covering is done. The conductors of rubber insulated wires and cables are of tinned copper and may be single wires, strands or bunches of wires. The machines here are making strands of various numbers. With stranding, as you have seen, the reels holding the single wires are rotated in the machine. When wires are bunched, however, the spools of fine wire are fixed on a frame, and the reel on which the completed bunch is wound is rotated at very high speed. Now let us turn to the preparation of the rubber used for insulating. It is of vital importance that the raw crepe rubber shall be absolutely clean, and great precautions are taken to ensure this. The raw rubber with various powders is mixed on mills with steam-heated rollers. After the mixing, the rubber is calendared into thin sheets, which are wound up between calico to prevent the layers sticking together whilst yet warm. Next, these sheets of rubber are cut into strips, ready for the covering machines. This is the rubber covering shop, where wires and cables of all sorts and sizes are covered with rubber. The usual method of covering is what is known as longitudinal. In this machine, 24 tinned copper wires or small strands are led from their reels into a flat band which passes into the machine with a strip of rubber compound above and below it and is fed through accurate grooved rolls which, acting by crushing and cutting the rubber, surround each conductor with a layer of the compound with a perfect seam on each side. According to the thicknesses of rubber required, this process can be repeated. As a general rule, 3 such layers are applied. This process is applicable to single wires and conductors which are not large in diameter. When larger strands are to be covered, the rubber compound in strips of the required thickness and width is lapped on the conductor. In this big machine, 5 such layers are being applied at the same time. These larger cables are used for main cables for motors and transformers and for service cables. Another type of cable, used for instance for house wiring, is covered with a tough rubber sheath. This tough rubber sheath, without seam, is extruded by pressure over the cable. The girls are laying rubber cable in the tray, ready for vulcanizing. After vulcanization, tough rubber sheath cables have the maker's name and grade of cable printed on the surface. All rubber insulated cables are tested in water in which they have been immersed for 24 hours. They are first subjected to a straining voltage, several times that at which they are intended to work. Some cables, as you have seen, are tough rubber sheath, while others are braided and compounded. Another type of finish consists of lead or alloy sheathing. The molten metal is charged to a lead press, which extrudes the lead or alloy under great pressure round the cable in the form of a seamless tube. Motorcar cables are provided with several different finishes, and one of the most common is an armouring of a spiral of bright aluminium wire. Most of the conductors you have seen are made of copper. In order to provide the exceptional flexibility required by telephone instrument cords, the conductors you see here are made of tinsel. Other machines are covering very fine wires with a layer of the purest quality silk. In some cases, wires so small as 1/1000th of an inch in diameter are covered. Before cables are dispatched from the works, they are wound onto suitable drums. Here is the alloy sheathed house wire being automatically measured and cut into 100-yard lengths. Such a large and varied output of cables and wires receives ample evidence in the finished material stores, where large stocks are kept ready for immediate dispatch to any part of this country or abroad. From the stores, goods are conveyed to the adjoining railway station by our own narrow gauge railway.